Lesson 11.2, Similar Triangle Theorems. Now, to prove whether or not triangles are similar, we have a few theorems to help us out. The first one is the AA Similarity Conjecture, which says that if two angles of one triangle are congruent to two angles of a second triangle, then the triangles are similar. For example, let's say that we were given these two triangles, triangle ABC and triangle DEF. Now here it's clearly illustrated that we have two angles in each triangle that are congruent to each other. Therefore, because of the AA similarity conjecture, triangle ABC is similar to triangle DEF. Here we have another pair of triangles, one actually embedded within the other. But first of all, we clearly have angle J congruent to angle L, and angle G, since it's the same angle in both triangle GHJ and triangle GKL, is also congruent to itself. So, because triangle GHJ and triangle GKL share two congruent angles with each other, then those triangles are similar. This is not the only similar triangle conjecture. There's also the SSS similarity conjecture, saying that if all three sides of one triangle are proportional to all three sides of a second triangle, then the triangles are similar. So say we were given these two triangles here, triangle ABC and triangle DEF. Now to prove that these two triangles are similar, we need to do a proportionality test between the sides. So let's test the scale factors between corresponding sides. First of all, we have side length AB corresponding with side length DE. That ratio there is 6 to 12, which works out to be 0.5. Then we have side length BC and side length EF. The ratio between those two corresponding sides is 11 to 22, also 0.5. And the same ratio can be discovered by comparing the ratio between AC and DF, 12 to 24, which also is a scale factor of 0.5. Because the scale factors between all three of these corresponding sides is equal, then we can conclude that triangle ABC is similar to triangle DEF. In addition, there's one other similarity conjecture, the SAS similarity conjecture, that says that if two sides of one triangle are proportional to two sides of a second triangle, and the included angle between those two proportional sides are also congruent, then the triangles are similar. In this example, let's say that we're given the following pair of triangles where one triangle again is embedded within the second, triangle GHJ and triangle GKL. Now clearly, angle G is congruent to itself in both triangles, so we already have an included angle that's congruent. But we still need to test for proportionality between the sides. So side length GH to side length GK is a ratio 25 to 35, whose scale factor works out to be approximately 0.714. Careful here with the scale factor. Make sure that you're not comparing just side length GH to side length GK. I'm sorry, side length GH to side length HK. Because side length HK is not a side length in triangle GKL. You need to use the full side length GK, which is what we did there when calculating that scale factor. Likewise, the ratio of length GJ to length GL is 20 to 28, which also works out to be 0.714. So because we have two proportional side lengths between the two triangles and a congruent angle between the two triangles there, the same angle, angle G, we can therefore conclude that triangle GHJ is similar to triangle GKL based on the SAS similarity conjecture. Thus concludes today's lesson.